Right, thank you. Question number 2, we are given the initial mass of steam. Steam is just water in gaseous state. That is steam. And a certain amount of carbon. So we are not given the initial mass of carbon, or even the initial moles of carbon. Right, so it means it might not be necessary in the table. That is why they did not provide it to us. Right, the two are placed in a 2 cubic decimeter sealed container and allowed to react until equilibrium is reached. The reaction equation is given. Right, at equilibrium, it was found that the amount of carbon changed by 0.225 moles. Right, in the previous questions that we were looking at, you'll be given the number of moles at equilibrium or concentration at equilibrium. This time around, you are given the change in the number of moles. Okay, meaning that this value has to be in this row of change in moles. But you have to determine now whether that change will be negative or positive. So in this case, this is change of what? Of carbon, which is a reactant. And the reactant changes, it changes negatively. So it has to be a negative change. Okay, but before we go to that, let us first convert the mass of steam given to number of moles. Right. Our ratio first, 2, 1, 2, 1. Right, initial number of moles. Then we calculate the number of moles of the steam. H2O mass over the molar mass. Right, we are given the mass as 36 divided by 80. Which gives us 2. Right, so 2 moles of steam are initially present. Of carbon, it's a certain amount that we don't know, so we just put a dash there, or we can even put an X. Okay, initial number of moles of the products, 0 for hydrogen and 0 for carbon dioxide. Right, then we move to change in moles, which we are given for carbon as 0.225. And we agreed that the change will be negative change because it's a reactant. Okay, so now, like I always say, with the change of just one substance and the ratio, you can determine the changes of all the other substances. So we have our change in moles of carbon, we can determine the change in moles of water or the steam, change in moles of hydrogen, and change in moles of carbon dioxide. Right, what will be the change in moles of water or the steam? It's 1:2. So it means whatever comes here must be double this, because 2 is double 1. Okay, so you multiply this by 2, it will be negative 0.45. Okay, then for hydrogen, positive 0.45. It's also 1:2. So the ratios of water and hydrogen must be the same. The only difference will be in terms of the sign. Water is changing negatively because it's a reactant. Hydrogen is changing positively because it is a product. Right? Then carbon dioxide, positive 0.225. Same ratio, same change. Only different in the sign. The carbon dioxide, the product, which